This instructional video covers the removal, repair, and reinstallation of a Rotoclave pressure vessel lock ring. Shown on the screen now is an overview of the vessel. We're zooming in on the lock ring teeth, and you can see the screws that hold the pads and wedges in place, and we're looking through the lock ring at the far side tooth, and that little V-shaped piece is a keeper, K-E-E-P-E-R, holding in a plastic pad. This is another keeper holding in a metallic pad. So the metallic pads are every other pad, and then in between the metallic pads are the plastic pads. And we're going to be replacing or re-welding the keepers today. This is a glide block. The glide block is a low friction block of plastic. There are 5 on the back of the lock ring, and this centers the lock ring and guides its rotation. In order to remove the lock ring has to be rotated until the teeth on the vessel side of the lock ring are aligned with the gaps on the vessel ring of the door. One of the first things you'll have to do is to disconnect the hydraulic cylinder that rotates the lock ring so that the lock ring can be rotated beyond its normal rotation. When the lock ring is rotated into the correct orientation, you'll be able to see light between the gaps between the teeth on the lock ring and the teeth on the vessel ring. Once the lock ring is rotated into the orientation where it can be removed, in order to actually get the lock ring to come off of the vessel, we will have to remove the glide blocks. Here the mechanic is removing the cover that holds the glide block into the glide block holder. Sometimes the cover will need a little persuasion to get it to come off. Now we can see the glide block. To help us get the glide block out, we might have to tap from the front side of the vessel while we're pulling the glide block out from the back. You can only do this if you take the load off of the glide block. The back of the glide block is rounded. Sometimes the corners will be rounded, but more importantly, the face that touches the ring will be curved, as this mechanic is attempting to show us here. The covers also have numbers that correspond to numbers that are stamped into the ring. We recommend that as you take the parts off of the Rotoclave, you keep track of which shims came from which glide blocks and which covers went with which glide blocks. Because although they're intended to be interchangeable, sometimes some fit better than others. Here the mechanic has very carefully laid out his parts so that he can keep track of them. We're going to show how to use a forklift to remove the ring. These mechanics prepare the forklift by spreading the forks to their full width and locking them in that position. The mechanics will begin by carefully positioning the forklift so that the blades are under the lock ring in the correct location. You'll notice that the mechanics communicate with each other quite a bit, hand signals, verbal, as the mechanic who's working asks the forklift operator to position the fork in the correct location. The mechanics are going to try to basically take a little bit of the weight off of the ring so that they can get the ring to be just centered on the vessel ring. A little bit of rotation back and forth, keeping your fingers clear to not be pinched, grabbing areas where you can move the ring without pinching your fingers, using pry bars to push the ring back and forth, rotate, lift slightly. When the ring is lined up just right, it will come off easily. The mechanic is shown lifting the ring with a strap here, but the exact method of lifting is left up to the mechanic doing the work. Here we're using fork extenders on the forklift to handle the ring, to set it flat on the jacks so that the welder can work at a comfortable elevation. The most important thing is, if you are going to put the ring on a set of jacks, to be careful as you lower the ring that it doesn't try to kick the jack out and swing and cause an injury. Here we have numbered all of the wedges, and we will number all of the pads so that when we put them back in, they go back in exactly the correct location. A close-up view of a wedge, tapered, the keeper on either end, which is necessary to hold the plastic wedge so that it doesn't slide. The screw only is supposed to provide a downward force and not experience a sliding force. The pad on the opposite side of the lock ring, notice the constant thickness. The keeper on either side. Here the mechanic is removing the screw that holds the wedge in place, and he's done this a few thousand times, so he's pretty talented at taking the screw almost all the way out, giving it a little bit of a tap to help the wedge come out. I would caution you that the plastic is very high strength but also brittle as a result, so that if you do that a little too hard, you'll break the wedge. Here the pads are just shown numbered with letters instead of numbers. The welder begins by buffing away the paint where he's going to weld. Notice the brass fit-up plug between the keepers that's bolted in place to hold the keepers in the correct location. This is especially important if you're going to be installing a new keeper. The keepers are welded most easily using a TIG process, gas tungsten arc welding with a 3/32 inch filler wire, and I would recommend a 3/32 inch gas tungsten. After welding, the weld should be approximately this size. Here the welder is shown moving the fit-up plug from one tooth to the next. He moves pretty quickly. It's hard to see, but he's using a special shoulder bolt that forces the screw to be centered in the hole. The shoulder bolt fits tightly in the drilled hole in the lock ring. Here the mechanic is reinstalling a pad. Now the ring has been flipped by the time he's doing this. He installs the screw, holds the pad down. Notice he doesn't use the screw to pull the pad down into place if it's a little tight. I'll warn you that if you're putting a brand new pad or wedge into the ring, it will need to be filed on the end very carefully to make it fit nice and tight, because the fit-up plug is very slightly smaller than the actual parts. If you have to use the forks through the lock ring to lift the lock ring, you should use a cushion between the forks and the lock ring to keep from causing damage to the ring. Here the ring is positioned in front of the vessel. The mechanics carefully rotate the ring to get it into its correct orientation so that when they lift it, it's ready to go onto the lock ring. Notice the mechanic is using the fork shifter on the lift truck to carefully align the lock ring. As you get the ring close to the vessel, you should keep your fingers from between the vessel and the ring. It would be a very nasty pinch. The mechanic stands on the forks and aims the ring, giving instructions to the forklift operator, up, down, left, right, and his two helper mechanics move the ring slightly, rotating the ring to cause the teeth to come into alignment. Notice how they wiggle the ring to get the teeth to come into alignment. By the way, those fingers are in the wrong place. A little bit of pry bar, a little bit of wiggle, and on it goes. Using the same glide blocks and the same shims, same number of shims, that we took out of each glide block holder. We placed the glide blocks back in their holders. A pry bar helps to lift the ring to get the glide block in place. A little bit of extra help with the pry bar and maybe a screwdriver to help lift the ring to create a gap between the glide block and the glide block holder to position the shims between the glide block and the holder, and then release the load, and the shim and the glide block should stay in place. Replace the cover. And tighten the bolts. You'll have best luck if you start by replacing the glide blocks on the top first. In the remove position of the lock ring, the glide block may be past the flat bar guide that's tacked to the vessel ring. So the lock ring may need to be pried forwards gently so that the glide block can slide past the end of the guide. Then rotate the lock ring into the orientation necessary to be able to reconnect the cylinder. After reconnecting the cylinder, recheck that everything is properly installed and properly torqued, and then slowly operate the lock ring back and forth. Listen carefully for things like a scrape or a drag. Look for any indication that something may not be installed correctly. When you're satisfied that everything is working fine, do a test cycle of the Rotoclave. From a safe distance, make sure that there are no steam leaks. When the cycle is over and the door is opened, re-inspect all of the parts, looking for scores or scratches or some other indication that something may not be just right.